Hi students, welcome to this section where we deal with work and rate. Alright, let's get started with the basics. Over here we have Mr. Cat and Mr. Fox. Now both of them are considering doing a piece of work. Alright, so we define this as 1 unit of work. It could be chopping 10 pieces of wood or 20 pieces of wood or whatever. But we define it as 1 unit of work. Alright, now Mr. Cat by himself can do this piece of work in 10 days. It's also given that Mr. Fox can do the same piece of work by himself in 5 days. Alright, so this means that Mr. Cat in 1 day can complete 1/10th of the work, right? Because he can complete the whole work in 10 days. So in 1 day, he can complete 1/10th of the work. Similarly, in 1 day, Mr. Fox can complete 1/5th of the work, right? Let me repeat. In 5 days, Mr. Fox can complete the whole work. Therefore, in 1 day, he can complete 1/5th of the work. Alright, now let's see how much of the work can be completed by both of them working together in 1 day. Now, there are two approaches in which we can approach this. The first one is using percentages. Now, Mr. Cat can complete 1/10th of the work in 1 day, and 1/10th of the work is 10% of the work, right? Now, similarly, Mr. Fox can complete 1/5th of the work, which is 20% of the work. So in 1 day, when they work together, they can complete 10 plus 20, that is equal to 30% of the work, right? So that is one way in which we can approach these type of questions, and using percentages is the faster way. But the only thing is that you should be well versed with the fraction to percentages conversion table. Now you can download this. It's provided as a downloadable resource. Now the more you internalize the percentage to fraction conversion, the better you can use this method. Now let's also see how this can be used using fractions. Now in 1 day, Mr. Cat can do 1/10th of the work, and Mr. Fox in 1 day can do 1/5th of the work, right? So together they complete 1/10 plus 1/5. That's equal to 3/10th of the work. So this is the approach where we use fractions, and you can notice that 3/10 is the same as 30%. Now if you can do these type of questions using percentages, it's faster. But the only criteria is you should know the fraction to percentage conversion table. Alright, now let's proceed. Now the same concept, whatever we discussed over here, is also applicable in the case of pipes and cistern based questions. Let's discuss that over here. Now over here I have a tank. Now say I have a pipe that can fill this tank in 10 hours. Similarly, I have one more pipe that can fill this tank in 5 hours. Now this means that in 1 hour, this pipe can fill 1/10th of the tank, right? And that is 10% of the tank. Why is that so? Because in 10 hours, it can do the whole tank. So in 1 hour, that's 1/10th of the tank. And remember, 1/10th is the same as 10%. You can also think of it as like this. In 10 hours, this pipe can do 100% of the work. Therefore, in 1 hour, it can do 10% of the work. That is filling the tank. Now, over here we have the other pipe. This pipe can fill the whole tank in 5 hours. Therefore, in 1 hour, it can fill 1/5th of the tank, which is equal to 20% of the tank, right? You can also think of it like this. In 5 hours, this pipe can do 100% of filling the tank. Therefore, in 1 hour, this pipe can fill 100/5, which is equal to 20% of the tank. Alright, now let's think of how much percentage of the tank will be filled if both the pipes are opened for 1 hour. So together in 1 hour, they can fill 10% plus 20%, which is equal to 30% of the tank. Now we can also do this using fractions. That would be 1/10 plus 1/5, which is equal to 3/10th of the tank. So these type of questions can be approached both using the percentage method or using the fraction method. Now in the subsequent problems, we will see both the methods applied, so that in any question you can easily choose which would be the best method to apply to quickly solve the question. Alright, let's get started with the questions. Let's do this question. Ash can complete a work in 20 days. Mahi can finish the same work in 15 days. If Ash and Mahi work together, then what is the total number of days needed to complete the work? Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Now, let's do this question both using the fraction method as well as the percentage method. Now, in one day, how much of the work will be completed if both of them work together? That would be 1 by 20 plus 1 by 15, right? Because Ash takes 20 days to do it alone. So in one day, Ash will complete 1 by 20 of the work, right? In a similar manner, Mahi, because he takes 15 days to complete the work, in one day, he'll complete 1 by 15 of the work. So together, it would be 1 by 20 plus 1 by 15. That's equal to 7 by 60 of the work. So in one day, they'll complete 7 by 60 of the work. So how many days will be needed to complete the whole work? That would be 1 unit, right? So that would be 60 by 7. How do you do that? 7 by 60 is the amount of work completed in one day. So in X days, let them complete 1 unit. So 7 by 60 into X is equal to 1. Therefore, X is equal to 60 by 7 days. Alright, now that's the way we do it using fractions. Now let's try to do the same question using the percentage approach. Now, in one day, how much of the work will be completed by Ash? That would be 1 by 20, which is the same as 5%, right? Similarly, in one day, how much percentage of the work will be completed by Mahi? That would be 1 by 15, which is equal to 6.67%. Now, for these fraction to percentage conversion, do refer the table provided as a downloadable resource. Alright, now when they work together, in one day, they'll complete 5% plus 6.67%, which is equal to 11.67% of the work. Now, to complete 100% of the work, how many days will be required? That would be 100 divided by 11.67. 11.67 is the same as 11 2 by 3. So we have 100 divided by 11 2 by 3. That's equal to 100 into 3 by 35. And on simplifying, you will again get back 60 by 7, which is the answer. And that is equal to 8 4 by 7, right? 60 by 7 is 8 4 by 7. And that is your answer, which is answer option A. Let's do this question. Ash can complete a work in 20 days. Mahi can finish the same work in 15 days. They worked together for 5 days, after which Ash had to leave. How many more days will Mahi need to complete the work? Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Now, when they work together, how much of the work will be completed in one day? That would be 1 by 20 plus 1 by 15, which is equal to 7 by 60, right? Ash takes 20 days. So in one day, Ash will complete 1 by 20 of the work. Similarly, Mahi takes 15 days. So in one day, Mahi will complete 1 by 15 of the work. Alright, now it's given that they work together for 5 days. So in one day, they complete 7 by 60 of the work. So in 5 days, they will complete 5 into 7 by 60, right? So that is equal to 7 by 12 of the work. Now, after 5 days have passed, how much of the work is remaining? So we have 1 unit of work to complete and 7 by 12 of that unit is completed. So the remaining part is 1 minus 7 by 12, which is equal to 5 by 12. So 5 by 12 of the work is remaining. Now in one day, Mahi can finish 1 by 15 of the work, right? So in X days, Mahi has to finish 5 by 12 of the work. That means 1 by 15 into X is equal to 5 by 12. And you can calculate X, right? X is equal to 5 by 12 into 15. That simplifies to 25 by 4 days, right? Which is equal to 6.25 days. That's answer option D. Now over here we use the fraction method. Now let's try to do the same question using the percentage method. We know that in one day when they work together, they'll complete 5% plus 6 2 by 3 percentage of the work, right? Because 1 by 20 is 5% and 1 by 15 is 6 2 by 3 or 6.67%. So 5 plus 6 2 by 3 is equal to 11 2 by 3, right? So in 5 days, how much will they complete? That would be 5 into 11 2 by 3, right? So 5 into 11 2 by 3 is 55 10 by 3, which is the same as 58 1 by 3 percentage. So in 5 days, they have completed 58 1 by 3 or 58.333 percentage of the work. So how much is pending? That would be 100 minus 58 1 by 3, right? So 41 2 by 3 percentage of the work is pending. Now Mahi in one day completes 6 2 by 3 percentage. So how many days will it take Mahi to complete 41 2 by 3 percentage of the work? That would be 41 2 by 3 divided by 6 2 by 3. Now in this division, you can see that the answer will lie between 6 and 7, right? 6 into 6 2 by 3, that's how much? That's 36 plus 6 into 2 by 3, right? So 36 plus 4. So 6 into 6 2 by 3 is equal to 40. And that is less than 41 2 by 3, which is the numerator. And 7 into 6 2 by 3 will be greater than 42, right? So that's greater than the numerator. Therefore, the answer has to be between 6 and 7. So looking at the answer options, there is only one answer option which lies in that range. So we don't even need to find the exact answer when we divide 41 2 by 3 by 6 2 by 3, and we get the answer as option D, that is 6.25 days. Let's do this question. Peter can finish a work in 10 days. Benji can do the same in 8 days and Christopher can do it in 5 days. Alright, Peter and Benji work on it for 2 days. After this, Benji leaves and Christopher joins. So that's just Christopher and Peter now. They both continue for 1 day. After this, Peter leaves and Benji comes back. Benji and Christopher complete the remaining part. Then they get $5,000 for the work. This amount is distributed among them in the ratio of the amount of work they did. How much money does Peter get? Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Now let's do it together. We have Peter, Benji and Christopher, right? Now Peter takes 10 days to complete the work. So in 1 day, Peter will complete 1 by 10 of the work, right? Similarly, Benji completes 1 by 8 of the work in 1 day and Christopher completes 1 by 5th of the work in 1 day. Now it's given that 2 days Peter and Benji are working on it. Alright, so Peter and Benji working on it for 2 days, they'll complete 2 into 1 by 10 plus 1 by 8 of the work, right? 1 by 10 plus 1 by 8 is for 1 day. So that's the amount completed in 1 day. Now to find the amount completed in 2 days, you multiply that with 2. So this simplifies to 36 by 80, which is equal to 9 by 20. So 9 by 20 of the work is completed. Now how much is remaining? That would be 1 minus 9 by 20, which is equal to 11 by 20, right? 1 minus 9 by 20 is the same as 20 minus 9 by 20, which is equal to 11 by 20. Alright, so by the time 2 days have passed, 11 by 20 of the work is remaining. Now it's given that after this happens, Benji leaves and Christopher joins. So for 1 day, Peter and Christopher work on it. So Peter and Christopher work on it for 1 day. So how much of the work will they complete in 1 day? That would be 1 into 1 by 10 plus 1 by 5, right? So this simplifies to 3 by 10, which is equal to 6 by 20. Alright, so they had still 11 by 20 of the work to do and they completed 6 by 20 of the work. So how much is pending now? That would be 11 by 20 minus 6 by 20, which is equal to 5 by 20. So 5 by 20 of the work is still pending, and at this point Benji and Christopher are completing this remaining part. So Benji and Christopher together in 1 day, they complete 1 by 8 plus 1 by 5 of the work. So in X days, they have to complete 5 by 20 of the work. So we write that x into 1 by 8 plus 1 by 5 is equal to 5 by 20, right? So x days, this is the amount completed in one day, and in x days they'll complete x into the amount completed in one day, and that has to be equated to 5 by 20 because that is the remaining part of the work. So on solving, we get that x into 13 by 40 is equal to 5 by 20, or x is equal to 10 by 13. So at this stretch, they don't even have to work for one day, they'll just have to work for 10 by 13 more days. All right, now let's keep this aside. Now at the end, we need to find out how much money Peter gets. So let's first find out how many days each of Peter, Benji and Christopher are working. So Peter is working for 2 plus 1, that is 3 days, right? He's working over here, that's 2 days, and he's also working over here, that's 1 day, right? So Peter is working for a total of 3 days. What about Benji? Benji is working for 2 plus 10 by 13 days, right? So Benji is working over here, that's 2 days, and Benji is also working over here, that's 10 by 13 days. So that's 2 plus 10 by 13, which simplifies to 36 by 13 days. What about Christopher? Christopher is working 1 plus 10 by 13, which is equal to 23 by 13 days, right? Christopher works 1 day over here, and Christopher works 10 by 13 days over here. So 1 plus 10 by 13 is equal to 23 by 13. Now because these two have a denominator of 13, we can write 3 as 39 by 13. Alright, now to find the amount of money that each of them gets, we need to divide the total amount, that is $5,000, in the ratio of the amount of work that they have done. So Peter has worked for 39 by 13 days, and in one day he completes 1 by 10 of the work, right? Similarly, Benji has worked for 36 by 13 days, and in one day he completes 1 by 8 of the work. Christopher has worked for 23 by 13 days, and in one day he completes 1 by 5 of the work. So we need to divide 5,000 in the ratio 39 by 13 into 1 by 10 is to 36 by 13 into 1 by 8 is to 23 by 13 into 1 by 5. So, right, this will be the amount of work that each of these have done, right? This is the number of days, and this is the amount of work completed in one day. So when you multiply them together, you get the amount of work completed by Peter. Similarly, over here you get the amount of work completed by Benji, and this is the amount of work completed by Christopher. Now when we need to divide 5,000 in this ratio, you can see that in each of these three parts we have 13 in the denominator. So let's cancel that out. Alright, now let's multiply throughout with 10. That is, I'm multiplying this and this with 10. So I get over here 39 by 10 into 10, that is 39 itself. This is 36 by 8 into 10, that would be 45. And over here I have 23 by 5 into 10, that's 23 into 2, which is 46. So this ratio over here is the same as 39 is to 45 is to 46. Alright, now let me make some space over here. Now we need to divide 5,000 in this ratio. So how do we do that? What is 39 plus 45 plus 46? That's equal to 130. So we have to divide 5,000 into 130 equal parts, and then we give 39 parts to Peter, 45 parts to Benji, and 46 parts to Christopher. Now in the question we just need to find the amount that Peter gets. So that would be 5,000 by 130 into 39. And over here let's simplify that. That's 500 by 13 into 39. So that's equal to 500 into 3, which is equal to 1500, and that is answer option D. So as per the question, Peter is getting $1,500. Hi students, in this video let's discuss the concept of negative work. Alright, so over here we have Cat, Fox and Bee, and the work at hand is building a wall. Now Cat can do this by himself in 5 days, and Fox can do it by himself in 20 days. Alright, now over here you can see that B is angry. So B is only thinking of destroying this wall, and B can destroy the completed wall in 10 days. Alright, now what is happening if all the three are engaging at the same time? Let's think what's the effect in one day. Alright, so in one day we can see that Cat would be building 20% of the wall, right? Why is that so? That would be 1 by 5, right? Because the cat would take 5 days to build the whole wall by himself. So cat would be doing plus 20% of the work. Fox would be doing 1 by 20, that is plus 5%, and B would be doing minus 10%, that is B would destroy 10% of the wall in one day, right? So the net effect in one day, if all the three are engaging at the same time, would be 20 plus 5 minus 10, which is equal to 15%. All right. Now, so in one day, they'll finish 15% of the wall. So to reach 100%, they would need 100 by 15 days, right? All right. So let's think of this also in terms of fraction. What would be the effect in one day? That would be 1 by 5 for cat, 1 by 20 for fox, and minus 1 by 10 for B, right? So that's 1 by 5 plus 1 by 20 minus 1 by 10, which is equal to 3 by 20. Therefore, to complete this project, they would need 20 by 3 days. And you can see that that's the same thing that we got over here. 100 by 15 and 20 by 3 is the same. Now let's think of negative work in the context of pipes and cisterns. So over here I have a tank, and there is a pipe that can fill this tank in 10 hours by itself. There is another pipe that can fill this tank by itself in 5 hours. And there is a draining pipe that can drain the completely filled tank in 8 hours. Now, what would be the net effect if all these three pipes are opened at the same time? So what would happen in 1 hour? Let's try to find that out. Now, this pipe takes 10 hours to completely fill this tank, right? So in 1 hour, it would fill 1 by 10 or 10% of the tank. Similarly, this pipe would fill 1 by 5 or 20% of the tank, and this pipe would drain 1 by 8, which is equal to 12.5% of the tank, right? So in 1 hour, what is happening is 10 plus 20 minus 12.5, which is equal to 17.5%. That is, in 1 hour, all these three, when opened together, will result in a situation where the tank is 17.5% filled. Now, to fill the tank completely, we would want to reach 100%, right? For that, how many hours are required? We would need 100 by 17.5 hours to fill the tank completely. All right. Now, let's also think of this in terms of fractions. Let me make some space over here. So what's happening in 1 hour? That would be 1 by 10 plus 1 by 5 minus 1 by 8, right? That is equal to 14 by 80. Now, therefore, we would need 80 by 14 hours to completely fill the tank. And you can see that 80 by 14 and 100 by 17.5 both are one and the same. Let's do this question. Pipe A can fill a tank in 5 hours. Pipe B can empty the tank in 10 hours. How many hours are needed to completely fill the tank, given that it is already 1/4 full if both pipes are opened together? Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Now, I have a tank over here, and there is pipe A and there is pipe B. It's given that pipe A can fill it in 5 hours. So in 1 hour, pipe A would be filling 1 by 5, that is 20% of the tank. Similarly, pipe B would be emptying 10% of the tank in 1 hour, because it's mentioned that it can completely empty the tank in 10 hours. So in 1 hour, the effect would be 1 by 10, which is 10%. Alright, so if both these pipes are opened, what is the net effect after 1 hour? That would be 20 minus 10, which is equal to plus 10%. Alright, now over here it's given that the tank is already 1/4 full. That means it's 25% full, right? Now, therefore, we just need to fill it 75% more. So how many hours would be required for that? In 1 hour, we fill 10%, right? So how many hours are required for 75%? That would be 1 by 10 into 75, right? So that's the same thing as h into 10 is equal to 75. Therefore, h is equal to 75 by 10, which is equal to 7.5 hours. Alright, so that's the answer to this question, which is answer option D. We can also think of this same question in terms of fractions. So what would be the effect in 1 hour? That would be 1 by 5, right over here, minus 1 by 10. So in h hours, they would have to fill 3 by 4th, right? Over here we have 1/4. So 1 minus 1/4 is 3/4. So 3/4 more has to be filled. So the equation becomes 1 by 5 minus 1 by 10 into h is equal to 3 by 4, right? On solving, you get h by 10 is equal to 3 by 4, or h is equal to 30 by 4, which is the same as 7.5 hours. Let's do this question. Pipe A can fill a tank in 5 hours. Pipe B can fill the same tank in 10 by 3 hours. Peter opened both the pipes simultaneously. He noticed that it took 2 hours more than the usual time it takes to fill the tank when both the pipes are opened. It was discovered that this was because of a hole. Find the time taken by the hole to completely drain the tank if the tank is full. Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Now over here I have a tank, I have pipe A, I have pipe B, and I have a hole, right? Now pipe A takes 5 hours and pipe B takes 10 by 3 hours if they were to fill the tank by themselves, right? Now because pipe A takes 5 hours, that means in 1 hour pipe A would fill 20% of this tank, right? That's 1 by 5. And pipe B would be filling 3 by 10 of the tank, which is 30%. Alright, so if they are open together, that would be 50%, right? So in 1 hour, they would be filling 50% of the tank. And on a normal day, to achieve 100% of the tank being full, that would require 100 by 50, which is equal to 2 hours. Alright, now on the special day, it's taking 2 hours more, right? So it took 2 plus 2 hours, which is 4 hours. Now in 1 hour, 100 by 4, that is only 25% of the tank got filled, right? So it should have filled 50% in 1 hour, but only 25% was filled. Now the difference is 50 minus 25, which is equal to 25, right? And this is because of the hole, right? That's why there is a reduction in the per hour filling of the tank. So this hole was able to empty 25% of the tank in 1 hour, right? So that means if this hole were to completely drain the completely filled tank, that would take 100 by 25, which is equal to 4 hours, right? And that is the answer, which is answer option B over here. Alright, now let's also try this using fractions. So what would be the effect in 1 hour? That would be 1 by 5 plus 1 by 10 by 3, right? That's equal to 5 by 10. So in 1 hour, if pipe A and pipe B is opened, 5 by 10 or 1 by 2 of the tank would have been filled, right? Now therefore it would just take 2 hours on a normal day to fill the complete tank, right? Because this is equal to 1 by 2, and 1 by 2 into 2 is equal to 1. Alright, now with the hole, it's taking 4 hours, right? So how does the equation change? That's 1 by 2 minus 1 by x is equal to 1 by 4, right? So we have 1 by 2 over here, and let the hole take x hours to completely drain the tank. So in 1 hour, the hole drains 1 by x of the tank, right? So 1 by 2 minus 1 by x. This is the net effect in 1 hour, and that is equal to 1 by 4, because 1 by 4 into 4 is equal to 1. And we have found that it's taking 2 plus 2, that's 4 hours for the 3 pipes together to fill the tank. So 1 by 2 minus 1 by x is equal to 1 by 4, and on solving we can get x is equal to 4, which is the same answer that we got when we approached this question using percentages. Therefore this hole would take 4 hours to completely drain the completely filled tank. Let's do this question. Alex can complete a work in 10 days. Benji can complete the same work in 8 days. John can complete the same work in 5 days. Alright, Alex and Benji work on the project on alternate days. How many days will it take to complete the job if Benji starts? Alright, pause the video, give it a try, and then let's do it together. All right, we are back. I hope you have given it a try. Let's do it together. Now, Alex takes 10 days to complete the work. So in one day, he would do 1/10th of the work. Similarly, Benji would do 1/8th of the work, and John would do 1/5th of the work, right? Now, over here in part 1 of this question, we have Alex and Benji working together, and it's given that Benji starts. So on day 1, Benji works. On day 2, Alex works, and they keep repeating that, right? So in 2 days, they would have covered 1/8 plus 1/10 of the work, right? That's equal to 18/80 or 9/40 of the work. All right, so that's 2 days over here. Now, if we repeat this 3 more times, that would be a total of 8 days, right? In 8 days, they would cover 9/40 into 4, right? Because in 2 days they are doing 9/40. So in 8 days they would do 9/40 into 4. That is 36/40. Now how much of the work would be remaining? That would be 1 minus 36/40, and 1 can be written as 40/40, right? So 40/40 minus 36/40 is equal to 4/40. So 1/10 of the work is still remaining. Now if Benji were to work one more day, he would cover 1/8, right? So that's greater than 1/10. So we don't need one complete day of Benji's work. Now say we need X days of Benji's work. Now in one day, Benji does 1/8 of the work. So in X days, Benji would do 1/8 into X, and that should be equal to the remaining part, which is 1/10, right? On solving, you can find that X is equal to 8/10 or 4/5. So that means a total of 8 plus 4/5 days is required for this job to get completed. So 8/8, 4/5 is the correct answer to this question. Remember, this is 2 days, right? 1, 2, 3, 4, 5, 6, 7, 8. That's this 8 over here. And then we need 4/5 more days of Benji's work. So 8 plus 4/5 is the answer. Now we can do this question using percentages also, right? So if they are working together, this is 12.5% and this is 10%, right? So in 2 days, they would cover 10 plus 12.5. That's equal to 22.5% of the work, right? Therefore, in 8 days, they would do 22.5 into 4, which is equal to 90% of the work. So 8 days have passed, 90% of the work is done, 10% of the work is remaining. In one day, Benji does 12.5%. So to complete 10%, we would need 10 by 12.5 days, which is equal to 4/5 days. Therefore, again, we get that a total of 8 plus 4/5 days will be required for the job to complete. All right. Now let's move to part B of this question. Alex and Benji started working together. Only Benji worked on the last 3 days. How many days were needed? All right, pause the video, give it a try, and then let's do it together. All right, we are back. I hope you have given it a try. Let's do it together. Now it's given that on the last 3 days, only Benji worked, and Benji completes 1/8 of the work in one day. So in 3 days, he would complete 3 into 1/8 of the work, right? So before the last 3 days happened, how much of the work should have been completed? That would be 1 minus 3/8, which is equal to 5/8, right? So 5/8 of the work was done by Alex and Benji together. So that means 1/10 plus 1/8, which is the amount of work Alex and Benji do together in one day, into X is equal to this 5/8. So on solving, we get that 9/40x is equal to 5/8, or X is equal to 25/9. All right. So the total number of days on which work happened is 25/9 plus 3, right? All right. Now we can do this using percentages also, right? So in the last 3 days, Benji would have done 12.5 into 3% of the work, right? So before the last 3 days, 100 minus 3 into 12.5% of the work should have been completed. That's equal to 62.5, right? Now, when Alex and Benji work together in one day, they do 22.5% of the work. We have seen that this is 10% and this is 12.5%. So in one day, when they work together, they do 22.5% of the work. So in how many days will they complete 62.5% of the work? To obtain that, we equate 62.5 with x into 22.5, right? Therefore, x is equal to 62.5 by 22.5, and the answer is 3 plus 62.5 by 22.5, which is the same thing that we got over here. All right, now let's move on to part C of this question. Alex and Benji work together for 2 days. On the third day, John joins them. How many days more are needed? Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Now, Alex and Benji are working on this for 2 days. So, in 1 day, we know that they complete 1 by 10 plus 1 by 8 of the work. So, in 2 days, they will complete 2 times 1 by 10 plus 1 by 8, which is equal to 18 by 40, right? Now, how much is remaining? That's 1 minus 18 by 40, which is 22 by 40 of the work is remaining. Now, the remaining days, all 3 of them are working. So, in 1 day, if 3 of them are working, they'll do 1 by 10 plus 1 by 8 plus 1 by 5. So, in x days, they'll do x into 1 by 10 plus 1 by 8 plus 1 by 5. And that has to be equated to the remaining amount of work, which is 22 by 40. Now, on solving, we get 17 by 40x is equal to 22 by 40, or x is equal to 22 by 17. Now, that's the answer to the question. We need 22 by 17 more days. Now, we can also do this using percentages. In 2 days, when Alex and Benji work, they'll complete 22.5 into 2, that is 45% of the work. Now, how much percentage of the work is remaining? That would be 100 minus 45, which is equal to 55%. Alright, now when all the 3 are working, this is 10%, this is 12.5%, and this is 20%. So, on 1 day, they'll do 42.5% of work, right? So, in x days, they will do x into 42.5% of work. Therefore, x is equal to 55 by 42.5, which is the same as 22 by 17, which is the answer we got over here. Let's move on to part D of this question. All 3 start working together. John and Benji left 2 days before the completion of the work. Find total number of days needed for the work. Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Now, over here we know that John and Benji left 2 days before the completion of the work. That means on the last 2 days, only Alex worked, right? Now, in 1 day, Alex will do 1 by 10 of the work. So, in 2 days, Alex will do 1 by 10 into 2, right? That's equal to 1 by 5 of the work. Therefore, before these 2 guys left, they should have completed 1 minus 1 by 5, which is equal to 4 by 5 of the work, right? Now, when all 3 were working together in 1 day, they'll do 1 by 10 plus 1 by 8 plus 1 by 5 of the work. So, in x days, they'll do 1 by 10 plus 1 by 8 plus 1 by 5 into x, and that has to be equated to the amount of work that was already finished before they 2 left, which is equal to 4 by 5. Now, on solving, we get 17 by 40x is equal to 4 by 5, or x is equal to 32 by 17 days. So, the total number of days on which work happened is 32 by 17 plus 2. That is the answer to this question. Now, we can do this question also using percentages, right? Now, how do we do that? On the last 2 days, Alex is working 10% and 10%. That's a total of 20%. So, before John and Benji left, they should have completed 80%, right? And when all 3 are working, this is 10%, this is 12.5%, and this is 20%. Therefore, 42.5% of work is completed in 1 day. Therefore, in x days, 100 minus 20, that is 80% of the work has to be completed. Therefore, x is equal to 80 by 42.5, which is the same as 32 by 17. And therefore, the answer to this question is 32 by 17 plus 2. Let's do this question. a snail is trying to escape from John's glass bottle. Every day the snail climbs up 20% of the bottle during daytime, but in the night slips back 15%. How many days will it take for the snail to escape? Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. So the snail climbs up 20% and slips back 15%. So the net effect in a day is 5% upwards. Alright, so a lot of students might do it like this. In one day, that's 5%. So to achieve 100%, that would be 1 by 5 into 100, right? So therefore, they might mark the answer as 20 days, which is answer option A. But this is wrong. This is not the correct answer. Let me try to explain. Now over here we have that the snail first moves up 20%, right? Now what's 100 minus 20? That's equal to 80%. So how many days is required for the snail to reach 80%? That would be 80 by 5, which is equal to 16 days. Now on the 17th day, what happens? On the 17th day, the snail will move 20% up, right? It has already reached 80%, and 80 plus 20 is equal to 100%. That is, it comes out of the bottle. It no longer slips back. Therefore, the correct answer to this question is 16 plus 1, which is equal to 17 days. Now the problem over here is this does not happen simultaneously, right? In questions where we had a pipe filling the tank and at the same time another pipe draining the tank, these two things were happening simultaneously. But over here, it's not simultaneously, it's one after the other. That's why you need to be careful with these type of questions. And the correct answer to this question is 17 days, which is answer option E. Let's do this question. A snail is trying to escape from John's glass bottle. Every day the snail climbs up 15% of the bottle during daytime, but in the night slips back 8%. How many days will it take for the snail to escape? Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Now the snail is moving up 15% and slipping back 8%. So the net effect in a day is 7% upwards. Alright, now over here we have 15%, which is what the snail is moving up. So 100 minus 15 is equal to 85%. Let's check how many days it will take for the snail with this effective rate to reach 85%. So that would be 85 by 7, which is equal to 12, 1 by 7. Now let me discuss two methods in which you can proceed from here. Now what would be the snail's position on day 12? That would be 12 into 7, which is equal to 84%. So the snail would be 84% up on the glass bottle. What happens on the next day? The snail climbs up initially 15%. So 84 plus 15 is equal to 99. Then again slips back 8%. So 99 minus 8 is equal to 91%. On the next day, what happens? The snail starts at 91%. So the snail just needs to move 9% up and it crosses the bottle, right? So we have 12 days over here, and this happens in one day, and this is the next day. So a total of 12 plus 1 plus 1, that is 14 days is required for the snail to escape. And that is answer option A. Now over here you could also have seen that this is greater than 12, right? 85 by 7 is 12, 1 by 7. So that's greater than 12. So directly you could have taken 13. So what happens on day 13? 13 into 7 is equal to 91. So the snail is at 0.91%, and on the next day it just needs 9 more extra percentage. It can actually move up to 15% up. So on the next day, that is 13 plus 1. On the 14th day, the snail will come out. Let's do this question. Pipe A can fill a tank in 5 hours. Pipe B can empty a tank in 10 hours. And pipe C can fill the tank in 4 hours. Pipe A is open for 1 hour. Then pipe B is open for 1 hour. And then pipe C is open for 1 hour. This pattern is continued. How long does it take to fill the tank? Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Now here we have 3 pipes. Now pipe A can fill the tank in 5 hours, pipe B can empty it in 10 hours, and pipe C can fill it in 4 hours. So in 1 hour, pipe A will fill 20% of the tank, that is 1 by 5. Pipe B will empty 10% of the tank, that is 1 by 10. And pipe C will fill 25% of the tank, which is 1 by 4. So the net effect in 3 hours is 20 minus 10 plus 25, which is 35, right? So after 3 hours, the tank would be 35% full. Now we know that over here this is 20%, right? So we need to be careful when we reach close to 80%. 100 minus 20 is 80%. So what happens in the next 3 hours? That is, in a total of 6 hours, the pipe would be 35 into 2, which is 70% full, right? Now what happens after 1 hour? After 1 hour, that is after 7 hours, that is 6 plus 1 is 7, right? The tank would be 70 plus 20, that is 90% full. Now if one more hour passes by, that would be 80%. 90 minus 10 is 80% full, right? Now we are left with 20 more percentage to be filled, right? Because it's already 80% filled. Now it's pipe C's turn. Pipe C can fill 25% in 1 hour. So that's what we have. In 1 hour it can fill 25%, but we just need 100 minus 80, which is 20%. So how many hours are required? That would be 1 by 25 into 20, right? That's 20 by 25 hours. So we need a total of 8 4 by 5 hours. Remember, 20 by 25 is the same as 4 by 5. So the correct answer is option B, that is 8 4 by 5 hours. Now you can also observe over here that if you just divide 100 by 35, you would get 8 4 by 7 as the answer, and that is wrong, right? And that is given as answer option A, and that is a wrong answer. The correct answer is answer option B, which is 8 4 by 5 hours. In this video, let's discuss a shortcut for a special type of problem. Now over here you have cat and fox. Now say they both together can complete a piece of work in C days. Now if cat alone is working on the same project, cat would take A days more. That means cat would take a total of C plus A days. Similarly, if fox were to work alone on this project, fox would take B days more than C. So fox would take C plus B days to complete the work alone. So if this is the case, then directly you can say that C is equal to root of A into B. Now how do we get this? This comes from the fact that 1 by C plus A plus 1 by C plus B is equal to 1 by C. Now when you solve this, you will get this part over here. Now what is this? This is the work done in 1 day by C, by cat, right? Because cat needs C plus A days. Similarly, this is the work done in 1 day by fox, and it's given that together they need C days. So together in 1 day they will complete 1 by C of the work. Therefore 1 by C plus A plus 1 by C plus B is equal to 1 by C, and on solving this we get that C is equal to root of A into B. Now let's do a question which is based on this interesting concept. Bob and John are ready to complete a job. If Bob alone does the job, it will take 4 days more than they working together. If John does the work alone, it will take 16 more days than they working together. How many days will it take if they work together? Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. You can directly say that the answer is root of 4 into 16, which is equal to 2 into 4, that is 8 days. That is answer option A. Now you can see that Bob takes 4 days more than 8 days. So Bob takes 12 days. Similarly, John takes 16 days more than 8 days. So 16 plus 8, that's equal to 24 days. Now if they are working together, that would be 1 by 12 plus 1 by 24, and on solving this, this is equal to 1 by 8. Now if in 1 day they complete 1 by 8 of the work, they'll take 8 days to complete the work together, and that's how we got the answer as option A, that is 8 days. Hi students, in this video let's discuss work as man days or man hours. Now previously we had defined work as a unit, right? We took work given as one unit and we discussed how much percentage of the work would be completed in one day, etc. Alright, now another way of thinking of work is work is equal to work rate into time. Now work rate is work in a given amount of time, and when you multiply that with time, these two get cancelled out and you get work. Now if workers have the same efficiency or rate of working, then work rate is defined by the number of men who are working for the job. Now let's take an example. For example, we have a work and we found that it takes 3 men 2 days to complete this work. That means that this work is equivalent to 3 into 2, that is 6 man days. What does this mean? It means that if we were to hire 6 men, we could have completed this work in 1 day. Over here also you have 6 men into 1 day, which is equal to 6 man days, and that's the same thing that we have over here. Now instead of days, if you have hours, that's the case where you have man hours. Alright, now let's keep this aside and understand this in a better manner. Now say that the work over here has increased. Say it increased by 32%. Alright, now what do? Now we know that work is equal to work rate into time. Now to take care of this increased work, we can have multiple approaches. But at the end, this product over here also has to increase by 32%, right? Because work is equal to work rate into time and work has increased by 32%. Alright, so one way of dealing with this would be keep time constant but increase the number of men by 32%. Or you could keep the number of men constant and increase the time given to complete this work by 32%. Or you can do a combination. For example, you can increase the men by 10% and increase the time given by 20%. Now over here in the third case, what's happening? Say the product is 100. So one parameter in the product is increased by 10%. So from 100 you go to 110, and the other parameter is increased by 20%. So you go from 110 to 132. So what's the net change? So you're going from 100 to 132. So we know that percentage change is change by initial value. So the change over here is 132 minus 100, which is 32, and the initial value is 100 into 100. So that's a 32% change, which is what we had over here. So this is various ways in which you can deal with an increase in work. So let's quickly recap. Work is equal to work rate into time. That's how we define work in terms of man days or man hours. So if a work takes 3 men 2 days, we say that that work is equivalent to 6 man days. Let's do this question. 10 men can build a house in 12 days. 15 men are hired. How many days are needed to complete the house? Now pause the video, give it a thought, and then let's do it together. Alright, we are back. I hope you have given it a thought. Let's do it together. Now, the first method with which we can solve this question is using the concept of man days. Now, to build the house, it takes 10 men 12 days. So 10 into 12, that is 120 man days. So this job is 120 man days. Now, if you have 15 men, still the job is still 120 man days. So 15 into D number of days should be equal to 120 man days. Therefore, on solving, we get that D is equal to 120 by 15, which is equal to 8 days. Alright, so that's one method of solving this question, and the answer is option A. Now, another method with which we can solve this is using the product constancy rule, right, which we have discussed already before. Now, over here, we know that men into days is constant, right, because the work is constant. That's the work, right? This is constant. So over here, men have changed from 10 to 15, right? So we are going from 10 to 15. That is an increase by 1 by 2. So when men is increasing by 1 by 2, to keep the product constant, days has to decrease by 1 by 3, right? We have already discussed this. So days has to decrease by 1 by 3, right? Now therefore, days has to go down from 12 to 8. How do we get 8 over here? That's 12 minus 12 into 1 by 3. a decrease by 1 by 3. And that gives the answer as 8, which is answer option A. Let's do this question. Jacob is building a wall. He hires 10 workers to work on this project. He estimates that the wall will be ready in 30 days. At the end of the 15th day, he estimated that 50% of the work would be completed. However, only 30% of the work got completed. How many more days are needed to complete the work? If he wants to finish the work on time as planned, how many more workers should be hired? Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Now, in 15 days, only 30% of the work was completed, right? And there were 10 workers. Now, if you want to complete 100% of the work at the same rate, how many days would that take? That would be 15 by 30 into 100, right? Which is equal to 50 days. So to complete the job, you would need a total of 50 days, and that is 50 minus 15, which is equal to 35 days more. All right. Now, let's find the next part using the first method. How many more workers would be needed if he wants to finish on time? All right. Now, 10 workers, when they worked for 15 days, that's 150 man days, right? And it's given that only 30% of the work was completed. So it means that 150 man days is equal to 30% of the work. Now, therefore, 100% of the work would be 150 by 30 into 100. That is equal to 500 man days, right? How did we get this over here? That's 150 by 30 into 100, right? So that gives you 500 man days as the total work. All right. Now, already 150 man days is over. It's completed. 30% of the work is completed. So how much of the work is remaining? That would be 500 minus 150, which is 350 man days. Now, we need to finish it on time. That is, we have 15 more days and we need to find out how many men are required. So 350 man days is equal to X men into 15 days. On solving, we get that X is equal to 70 by 3, and that is equal to 24 men. Now, 70 by 3 is not exactly 24. That's 23 1 by 3, right? But you can't hire 1 by 3 of a man. Therefore, we have to hire the next higher whole number, that is 24 men. All right. Now, let's see one more method with which we can solve this. Let's keep this aside. All right. So, we have method 2 over here. Let me demarcate this area. Now, over here, we know that work done is equal to work rate into time, right? Now, over here, we need to keep the time constant. That's what we are trying to do, right? Initially, it was 15 days, and on the second sprint also, it's 15 days. Now, we need to increase the work done from 30% in the first 15 days to 70% in the next 15 days, right? So, work done has to increase from 30% to 70%. That is an increase of 40 by 30, right? Change by initial value. So that's 40 by 30 into 100, which is 133% increase, right? Therefore, as time is constant, this change has to be accommodated by work rate. Therefore, the work rate has to also increase by the same percentage. Now, initially we had 10 workers. So let's increase 10 by 133.33%, and you get to 23 and 1 by 3, right? How do you do that? When 10 is increased by 100%, it becomes 10 plus 10, that's 20. And then you are left with 33.33%, which is 1/3 of 10. So you have to add plus 10 by 3. So you get a total of 10 plus 10 plus 3 1 by 3, which is 23 1 by 3. Now, as you cannot hire 1 by 3 of a man, we need to hire 24 men. And that is the correct answer to this question. So what's the correct answer? We have 35 days over here and 24 men, which is answer option E. Let's do this question. Joshu loves math. He wanted to get his house built. He hires 1 worker on the first day, 2 on the second day, 3 on the third day, etc. In this way, every day he keeps on adding 1 more worker. The construction of the house finished in 30 days. Joshu spent $15,000 on the salary of workers. Every worker is paid an equal amount for a day's work. Find the maximum amount earned by a worker. Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Now, it's given that the work completes in 30 days, right? Now, on the first day, he is hiring one worker. On the second day, he is hiring two workers. On the third day, it's three workers. So he's keeping on adding one extra worker every other day, right? Every next day. So on day one, a total of one worker is working, right? On day two, that's two workers. On day three, that's three workers, and it goes on like that. So on day 30, he would have 30 workers. So the total number of man days that this work went on would be 1 plus 2 plus 3 etc. up to 30, right? And that is equal to 30 into 31 by 2. That is derived from 1 plus 2 plus 3 etc. up to n is equal to n into n plus 1 by 2. Now you can see more of this in the section of numbers, so you can refer it there. We deal with this in detail over there. Alright, so 1 plus 2 plus 3 etc. up to 30 is equal to 30 into 31 by 2, and this is equal to 465, and this is man days, right? This is one man day, this is equal to 2 man days, this is 3 man days, etc. So this 1 plus 2 plus 3 etc. up to 30 is equal to 465 man days. So the work is 465 man days. So it's equal to hiring 465 men for one day. Now, if 15,000 is divided equally among 465 men, how much money would one person get? That would be 465 into x is equal to 15,000, or x is equal to 15,000 by 465. So this is the salary that a worker gets for one day. Alright, now over here we need to find out the maximum amount earned by a worker. That would be by worker 1, because he'll be working for 30 days, right? In one day he makes this much amount. So in 30 days he would make 30 into 15,000 by 465, right? So that's approximately 30 into 1000 by 31. Now over here you have 30 and over here you have 31. So approximately you can cancel this out and your answer should be very close to 1000, a little bit lower, right? Because the denominator is higher than the numerator. So your answer should be close to 1000 but a little bit lower than 1000. And there is only one answer option among the 5 answer options that satisfies that, which is option A, that is 968. Therefore, the correct answer to this question is option A, that is 968. Hi students, in this video, let's discuss a scenario where work is taken as the volume of work. Now, let me take an example to explain this. We have two walls over here, and let's define the length, breadth and height of these two walls as L1, B1 and H1 for this wall, and L2, B2 and H2 for this wall. Alright, now let M1 men take D1 days, and every day they are working T1 hours for building this wall over here, right? So M1 men are working D1 days and every day they are working T1 hours for building this wall. Now let the parameters for this wall be M2, T2 and D2. Alright, now over here we can say that L1 B1 into H1, that is the volume of this wall, which is L1 B1 H1. The volume of this wall is L2 B2 H2. Now if we take the ratio of the volumes, that would be equal to the ratio of the man hours. So L1 B1 H1 by L2 B2 H2 is equal to M1 T1 D1 by M2 T2 D2. Over here, what is this? This gives you man hours, right? This is men, M is men, and T is hours per day. So that's hours per day, and then you are multiplying with days, right? So you get at the end man hours. Similarly, over here also you get man hours, and man hours in this case is proportional to the volume of the wall. So in this case, we can say that L1 B1 H1 by L2 B2 H2 is equal to the ratio of the man hours in case 1 to case 2. Alright, now let's read a question to understand this in a better manner. John, a contractor, observed that 10 men working 10 hours per day can build a wall of length 100 meters, breadth 5 meter and height 8 meter in 5 days. Help him estimate how many men he will have to hire to complete a wall with dimensions as length 200 meter, breadth 4 meter and height 10 meter in 4 days, given that the men will work the same number of hours per day. Alright, now over here we know that the ratio of the volume of the two walls will be equal to the ratio of the man hours. That is, we can say that 100 into 5 into 8, that's the initial volume, divided by 200 into 4 into 10, that's the final volume, will be equal to 10 into 10 into 5, right? It took 10 men and it was 5 days, and every day they are working 10 hours. And in the second case, we have m men and they are working the same number of hours per day, and we just have 4 days. Now on solving, we get that m is equal to 200 by 8, which is equal to 25. Therefore, this contractor will have to hire 25 men. Hi students, in this video, let's discuss efficiency based problems. Alright, now over here I have two people, I have panda and hen. Now say it's given that panda is twice as efficient as hen. So what does this mean? It means that in the same time, panda does 2 times the work as hen, right? In the same time, panda does 2 times the work as hen. Or it means that to do the same work, panda will need half the time that hen takes. So you can see that efficiency is inversely proportional to time. That is, if efficiency increases, the amount of time taken for a work decreases. Similarly, if the amount of time taken to complete a work increases, that means the efficiency is reducing. Alright, now over here it's mentioned that panda is twice as efficient as hen. Another terminology that you might see in questions is, it may say that panda is 2 times more efficient than hen. So both of these are different. Over here you have 2 times more efficient than hen. This means that panda is thrice as efficient as hen. That is 2 times more. That is 1 plus 2, which is equal to thrice, or 3 times as efficient as hen. Now if panda is 3 times as efficient as hen, then in the same time panda would do 3 times the work as hen, and to do the same work panda would need 1 by 3 the time taken by hen. Let's do this question. Bob, John and Tanya are working on a project. Bob takes 20 days to complete the work alone. John is twice as efficient as Bob and Tanya is thrice as good as John. How many days will they take together to complete the work? Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Now over here we have Bob, John and Tanya. Now it's given that Bob takes 20 days to complete the job on his own, right? So in one day he would do 1 by 20, that is 5% of the work. Now it's given that John is twice as efficient as Bob. That means in one day he will complete 2 times the work, that is 10% of the work. And Tanya is thrice as good as John. So in one day Tanya will complete 3 into 10, that is 30% of the work. Therefore, if they are working together in one day, they will complete 5 plus 10 plus 30, that is 45% of the work. Now in one day they are doing 45% of the work. So how many days will they need to complete 100% of the work? That would be 100 by 45, right? Which is equal to 2 by 9 days. And that is answer option D over here. Alright, now we can also do this using the fraction method. Let's quickly see how it would look over here. But over here you can clearly see that the percentage method is the best method. But let's just see the fraction method also. Now Bob takes 20 days, right? So John would take 10 days because John is twice as efficient as Bob. And Tanya would take 10 by 3 days because Tanya is 3 times as good as John, right? Now in one day, Bob would complete 1 by 20 of the work, John would complete 1 by 10 of the work, and Tanya would complete 3 by 10 of the work. So together they would complete 1 by 20 plus 1 by 10, plus 3 by 10. That's equal to 9 by 20 of the work. So they would require 20 by 9 days to complete the work, which is the same as 2 by 9, and therefore the answer to this question is option D. Let's do this question. Bob and John can complete a work in 10 hours. Bob is twice as efficient as John. How much time will it take Bob to do the job alone? Alright, now pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Now, without solving this directly, just using logic, you can mark the answer as option A, right? Because both of them together, it takes 10 hours. Now, Bob is twice as efficient as John, but still, if Bob is doing the job alone, it would take him more than 10 hours, right? Now, there is only one option which is greater than 10. Therefore, the correct answer is option A, that is 15 hours. Alright, now let's proceed and see how to get this. Now, together, they would take 10 hours, right? That means in 1 hour, together they'll complete 10% of the work. Now, we need to distribute this 10% among Bob and John. Now, it is given that Bob is 2 times as efficient as John, right? So, how do we distribute the percentage of work done? We divide 10 into 1 plus 2, that is equal to 3 equal parts, and we give 2 parts to Bob and 1 part to John. That means Bob would have completed 2 by 3 into 10% and John would have completed 1 by 3 into 10%. Now this is in 1 hour. Therefore, in 1 hour, Bob is doing 2 by 3 into 10%. Therefore, how many hours would be required to do 100%? That would be 100 divided by 2 by 3 into 10, right? And on simplifying this, you get this as 5 into 3, which is equal to 15 hours. And that is answer option A. Let's do this question. John, Peter, Bob and Andy are 4 friends. John works twice as fast as Bob and Peter works 3 times as fast as Andy. John takes 4 days more to complete a project compared to John and Peter working on the project together. Peter takes 9 days more to complete the same project compared to Peter and John working on the project together. If Bob and Andy work together on the project, how many days will it take? Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Now over here we have 4 friends. That's John, Peter, Bob and Andy, right? Now it's given that John works twice as fast as Bob. So if in 1 hour Bob completes X percentage of the work, John would do 2X percentage, right? Now you can take it as 1 hour or 1 day. In 1 day, if Bob does X percent, John would do 2X percent. Alright, now it's also given that Peter works 3 times as fast as Andy. So if in 1 day Andy completes Y percentage of the work, Peter completes 3Y percentage. Alright, now over here it's mentioned that John takes 4 days more to complete a project compared to John and Peter working together, and Peter takes 9 days more compared to John and Peter working together. So we have seen this before. This is a special case. Directly we can say that John and Peter together will need root of 4 into 9, that is 6 days to complete the work, right? And it's given that John takes 4 days more. So John takes 6 plus 4, that is 10 days to do the work by himself, and Peter would take 9 days more. So 6 plus 9 is 15 days. So Peter needs 15 days to complete the job by himself. Alright, now John needs 10 days. Therefore, in 1 day he does 10%, that is 1 by 10 of the work, and Peter does 1 by 15, that is 6.67% of the work, right? Now we know that John does 2x percentage in a day, and that is equal to 10%. Therefore, x is equal to 10 by 2, which is equal to 5%. And we know that 3y is equal to 6.67. So y is equal to 6.67 by 3, which is equal to 2 by 9%. Remember, 6.67 can be taken as 2 by 3. So that makes the calculation easier. Alright, now we need to find out how many days it would take Bob and Andy, if they are working together. So in one day, they'll do X percent plus Y percent. That is 5 plus 2 by 9%, right? Which is equal to 7 2 by 9%. So if they need to complete 100%, that would take 100 divided by 7 2 by 9, which is equal to 13 11 by 13 days, which is answer option B. Hi students, in this video, let's discuss questions where we have different groups of workers. Probably it could be men, women or children. Alright, so let's move ahead. We have a piece of work at hand and say it's given that 10 men take 8 days to complete this work. Now it's also given that the same work can be completed by 15 women if they work for 10 days. Now the question is, how many days would 5 men and 5 women need to complete the same work? Alright, now the approach over here is converted into 1 day. So over here you can see that 10 men need 8 days. So that's a total of 80 man days, right? 10 into 8 is 80. So this work is equal to 80 man days. Similarly over here, this is 15 women, 10 days. So that's equal to 150 or 15 into 10 women days. Now this is the same work. Therefore 80 man days is equal to 150 women days, right? So 80 man days is equal to 150 women days. What does this mean? It means that 80 men could complete this job in 1 day, right? And over here it means that 150 women could complete this job in 1 day. So the time period is same now. So that means 80 men do the same work that 150 women do, right? Therefore I can equate that 80 men is equal to 150 women. So I'm able to eliminate one variable, right? So 8 men is equal to 15 women, or I can say that 1 woman is equal to 8 by 15 man, right? Now I'm able to eliminate one variable. Now over here I have 5 women and 5 men. I can either eliminate women or men. Any one has to be converted to the other. So let's go ahead over here. I have 5 women. So 5 women is equal to 8 by 15 into 5. That is equal to 8 by 3 men. Alright. Now 5 men and 5 women. Therefore over here, this part over here is equal to 5 plus 8 by 3. That's what we found over here. Men, right? So that's equal to 23 by 3 men. Now we know that this work over here is 80 man days. Therefore 23 by 3 into days, right, is equal to 80, and we can calculate that the number of days required would be 240 by 23. Alright, now let's proceed and do an interesting question in this context. 3 men and 2 boys can do a job in 10 days. 5 men and 6 boys can do the same job in 4 days. Approximately how many days will it take 3 men and 10 boys to do 2 times the work? Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Now over here it's given that 3 men and 2 boys take 10 days to complete the work, right? Now it's also mentioned that 5 men and 6 boys take 4 days. Alright. Now the approach is the same. Let's convert these two into 1 day. So if they are just working for 1 day, how many men and women would be needed? You just need to multiply this, right? You just need to multiply this 3 with 10 and this 2 with 10. So we get 30 men and 20 boys. If they work for 1 day, it's the same number of man day and boy days that we get, right? Over here we have 30 man days and 20 boy days when we take this into consideration. And over here, if 30 men work for 1 day, again we have 30 man days. And if 20 boys work for 1 day, again we have 20 boy days. So these two have the same amount of work. Similarly over here, this part over here is equivalent to 20 men and 24 boys working for 1 day. Now the time is the same in these two scenarios. So I can equate these two together, right? So 30 men and 20 boys do the same amount of work that 20 men and 24 boys do. Now let's simplify this to eliminate one variable. I get that 10 men is equivalent to 4 boys, right? Now over here I have 20 boys. If 10 men is equal to 4 boys, what would be 20 boys equivalent to be? that would be 50 men, right? I'm multiplying this with 5, so I need to multiply this also with 5. So 20 boys, which is what I have over here, is equivalent to 50 men. All right, so this is a total of 80 men working for one day. Therefore, this job is equal to 80 man days. All right, now let's proceed. Now we need to find out how many days it will take 3 men and 10 boys to do 2 times the work. Now 2 times this work would be 80 into 2, that is equal to 160 man days. All right, now let's proceed. Now I have 3 men and 10 boys, right? So 160 man days is equal to 3 plus 25 into D. What is 25 over here? 10 boys, right? 10 boys will be equal to 25 men. How do I get that? We have over here that 4 boys is equal to 10 men, right? So 1 boy is equal to 10 by 4 men, and therefore 10 boys is equal to 10 by 4 into 10, that is 100 by 4, which is 25. So 10 boys is equal to 25 men. So we have a total of 3 plus 25, that's equal to 28 men working for D days to complete 160 man days of work. Alright, so we solve and we get that D is equal to 160 by 28, which is approximately 6, and therefore the answer to this question is option B, which is 6.